Good morning. My name is John McCrell. I'm from CIMdata. We're a consulting firm. I'll talk a little bit about our business here just for a second. The only thing that we do is strategic consulting around PLM, Product Lifecycle Management. And I'll define PLM for you in a few minutes. For us, it's a very broad area. It includes a lot of things, and I'll show you what some of those are in just a moment. So that is our business. We act as a kind of a translator between the vendors of PLM solutions. PLM, by the way, and I'll come back to this, is a strategy. It is not a solution. PLM is lots of solutions. So as I said, I'll come back to that. Some of our customers, particularly in the larger manufacturing sectors, and we have customers outside of these areas as well. A lot of them in emerging areas, but you can see who some of the folks are that we deal with on a regular basis. Lots of automotive, lots of aerospace, lots of high-tech products. Those are the big users of PLM strategies today. But this area is really spreading. So let me go into an introduction to the overall PLM market. This will be really quick. I only have a few slides. I want to talk a little bit about things that you may or should worry about, like developing. So for manufacturing companies, developing products in a tiered environment, how do you do that? What are some of the special issues that you have in a tiered environment? Global product development and delivery, because we are quite globalized today, and we're not going back to being single U.S. and all that focus. It just can't happen because we have too many companies that already are working on a global basis. Protecting your IP, of course, companies are very worried about their IP and where that goes and who has access, and how do you protect that? How do you keep people from seeing into the depth of what your product definition is with not allowing them to see all the details, but allowing them to get enough information that they can help you do your job. Really important part of this. Pay attention to the right things. So work on the things that are important to you. Don't spend a lot of time trying to find data. Don't spend a lot of time trying to do goofy searches and kinds of things that don't really produce for you the results and the information that you need to do your job. You want rapid ways to get to the data you need. And of course, I'm going to tie this back to what Actify has been talking about all morning. And how that works. Finding time to be innovative, right? Innovation, if you look at the IBM executive reports that come out every couple of years, innovation is always in the top 2 or 3 or 4 items on the C-level management's concern list when they look at these reports and do their kind of vote on this. Innovation is critical to companies being able to have a profit and being able to continue to grow the company in a good way. And then being able to use and reuse your high-value data. I like to talk about high-value data. You produce a lot of data. There's a lot of stuff that you produce because you have to for some particular operation. The high-value data is your deep design data. It's the stuff that you produce that's in 3D. It's the stuff that you produce that really defines the requirements and those kinds of things. You want to reuse those. You want to be able to go and find, right, the example of glass. You want to be able to go find, what did I do before? If I need to do another one of these things, can I find this quickly enough to produce a valid and reliable quote of what this is going to cost my customer? That's going to get me the business, right? If I can't produce a good and reliable quote, I'm likely to either lose the business, or if I win it, it may be unprofitable business, and I don't want that either. So let me go into our definition of PLM. It's a strategic business approach. So this is PLM on a grand scale. This is the kind of enterprise-wide thing that Jim talked about. Not a lot of companies do this, or let's put it this way. A lot of companies try to do this. Not a lot are successful at pulling off the grand PLM vision. in this. It's the collaborative creation, use, management, and dissemination of your product information, the stuff that defines your product, where your product can be anything, a mechanical thing, an electrical thing, some software, a process, right, a service that you do for other companies, whatever it is, it's a product in our view. This building, by the way, is a product. So it's a product for Marriott. They own this thing, they have to maintain it, they have to work with it, it's a product. So a real broad definition. It includes all the kinds of mechanical, electrical, AEC on here is architecture, engineering, and construction. EDA is electrical. ALM is managing software components, right? Formulas, specifications, portfolios, all the changes to those, all the processes by which you build them, and that sort of thing, right? It's an innovation platform that supports your extended enterprise. And remember, whether you're an OEM, a supplier, or a tier 2, right? A tier 1 supplier or a tier 2, you have an enterprise around you. You all have customers and you all have suppliers. So no matter practically what you do, you're consuming raw materials or you're consuming already manufactured parts, and you're providing those through some transformation to your customers. It's real important there. Spans the whole life cycle. And when we talk about the life cycle, if you go to the upper left, you've got the requirements coming in, what you have to build. You decide what you're going to make out of that through portfolio management. You go start to build it out and test it and validate that it works. You come around finally and build and produce it. You do quality testing. You sell the thing and distribute it. Maybe you maintain it in the field, maybe not, right? But in some way, there's some in-service component to this, replacement, whatever. And then finally, at the end of this thing, you can do a number of things. And we talk a lot about the circular economy. And in a circular economy, it's not only recycling stuff, it's repurposing, remanufacturing, recovering materials out of things that you do that have high value. So there's a lot of things that can happen at what we've typically have called the end of life. And what we would like to see is the life continues on, right? We don't want that end to be a hard end. A typical company looks a little bit like this, or a typical situation you would have for PLM. And remember, I said PLM's all these different things. The one part here that's not PLM is ERP. We don't count ERP in PLM because it's fundamentally a different kind of tool and software that's involved. Very transaction-based, where what we're trying to do on the PLM side is manage all the intellectual property up here, stuff that changes really rapidly. It's going through all kinds of transformation. The amount of information we're managing is way beyond just the parts that have to go together to produce a mechanical thing or to produce the product in the factory. So there's a handoff here. By the way, it can be a two-way thing, right? I might want to get cost information out of here that was discussed earlier and be able to use that in my calculations that I do up above. And my calculations that I do up above may be way beyond just cost of things. It could be profitability. You know, if I build this thing, am I going to be profitable? As I continue to build it, am I going to remain profitable? That kind of thing. Of course, you have all of the engineering stuff sitting over here on the left side. You've got project and program management. You've got documentation. You have product data intelligence. We often just call this visualization, but that's when you look at Actify, visualization is part of their story, but it's not the whole story. It's really about, let's look at the data and provide the data to people in a holistic way that they can go use it well beyond just the physical visible data, right? And then you have outsiders over here that you have to satisfy. And this group of outside suppliers can be very, very large. The other outsiders that are over here that are not on the chart are your customers, the consumers of what you're making. And the customer could be, again, any number of different types of organizations. If you're building a consumer product, it could be a Walmart, right? It could be a direct sell that you do. It could be through other distributors of various kinds, or different kinds of corporate relationships go on here in the customer relationship. It's really important that you understand what data has to flow across those interfaces. So just a kind of a schematic example here of some of the things that you need to be worrying about. We talk real quickly about the market. So we are the market measurers. One of the things that CIMdata does is, in addition to consulting, we do a lot of education, we do a lot of research. One of our research areas is measuring the PLM market and a lot of the components of the PLM market, which you see here. So we measure the CAD market, we measure the market around computer-aided manufacturing tools, where this goes, by the way, beyond just NC tools. It's really all about computer-aided manufacturing here. Simulation and analysis tools, other tools, electronic and architectural engineering construction tools, all of those kinds of things, the resellers, the support people, the systems integrators, we measure all of these. And we look at about 600 companies every year, and we're continually monitoring these companies to see where their marketplace is going, or their value in the space is going. And what we end up with out of here is we have about, in 2016, about a $40 billion market, and it's growing. And it continues to grow. Sarge, question?
Where do you categorize software as one of the manufacturing deliverables?
That is kind of buried in these other tools. So here's the ALM, the Application Lifecycle Management, which is where the software management would go. What we don't measure in there are the software engineering tools. So those tools that you would use to create software, right, and do the programming and that sort of thing, we don't measure those, but we do measure the management of it. Other tools we don't measure in here are things like Microsoft Office. If we did, the number would be all warped by their number, right? This number would go way, way up. I don't know how much they sell, how much Microsoft sells of Office at this point. I haven't looked lately, but it's billions and billions of dollars.
To the point that Chris was making, that everything is going towards managing IoT data?
Yes.
That number is, wherever that number is captured.
The IoT stuff is kind of again, in our other tools, but it's a little bit embedded through a lot of this. This thing up here at the top called CPDM, that's our terminology, collaborative product data management. That is PDM in the normal form. There's actually one other component in there that is not PDM. It happens to be Actify, and other viewing tools are embedded in that number. So it's a little bit funky. That's historical. It's gotten kind of crazy now, but it's hard to change how you measure these numbers once you get going. Yeah, and it really is difficult, by the way. So, and there's a lot of these. We always mark these slides. These are our estimates. We get the best data we can get from the vendors. We do a survey every year. We get the best data that we can, and then we go around and look at a lot of other information in the market space to estimate what the whole value of the market is. So our estimates. So it's a big market, and it continues to grow. Jim mentioned earlier, in 2009 we had a huge problem. And this is the first time in probably 15 years. By the way, I've been in the space. I'm an engineer. I'm a naval architect, so shipbuilding engineer. I've been doing things related to CAD and PDM since 1970. So I've been around the market for a very, very, very long time, before there were many CAD systems, actually. We had this big hiccup, and it's one of the worst times we had in the whole market. We recovered pretty quickly, surprisingly quickly. We went back to parity in the following year with the previous year. And now we're back on a growth path. So just a concept here. The colors, this is the PDM stuff, is the blue. The red is all the tools. The tools are the CAD solutions, the electrical CAD solutions, the visualization tools are buried down in here. But most of the tools are up in that red bit. And the little green stuff on top is the manufacturing tools. That's manufacturing planning. There's two big tools in there, Technomatics from Siemens and Delmia from Dassault. They dominate that little bit of market that's up there that's around $500 million right now. And here's how it breaks up in the areas. One thing I'll explain here is over here you'll see MCAD in here twice. This is the mainline CAD systems. There are 3 systems here. There's CATIA, there's NX from Siemens, and there's Creo from ProEngineer. Down here in this blue one, there's all of the the other CAD systems. Be careful with my words here. This is getting to be a little false too, because this includes things like SolidWorks. And if you look at SolidWorks today, it's quite different from what it was 10 years ago. SolidWorks now is a pretty multidisciplinary CAD solution on the market space. Electrical CAD is over up in the upper left. So it's separated out from mechanical CAD. Whoop. I went forward. Sorry about that. Okay, I can't back up, but that's, no, it did. All right, and then we have things like simulation analysis or computer-aided engineering, that kind of stuff sitting down in here. And we have digital manufacturing and some other areas on here. So a lot of different areas that we measure. We divide the market up into these various areas because we need to help companies understand, the vendors understand where they are, and then for you guys, what are the areas that are growing out here and what do I need to be looking at? If we look at this by industry, these kind of big boxes on here, we have super groups that are made up of these lower groups down here. What you see from this is most industries are growing, continue to grow. Historically, they've all grown. We have hiccups, right? So, aerospace and defense took a little dip 2 years ago, and automotive took a little dip 2 years ago. But what you see is some of the other industries have grown quite a lot. And then you have industries that in 2016 took a dip, like process petrochemical. Right? So, and then of course there's another group out here that we have to measure, because you have to have some place to throw in the companies that don't fit into one of the natural categories that we use. Let me talk a little bit about industry trends. So I'm going to focus a little bit on automotive. I think most of the people in the room are automotive. Probably most of the people on the webinar are automotive as well. But I will tell you that every one of the things that I've got on these slides applies to manufacturing industries. So they might not apply in the process industries. They might not apply in apparel and footwear and some of those areas, clothing kinds of things, but they apply for the audience that's here, right? And what I'm gonna do is hit these at a high level. I've got way too many slides of these. There's a lot of detail in here. You will have access to the slides. So you'll have all of this detail available to you, and you can read it. I suggest reading it just at bedtime, right? So automotive industry shifts to global markets and globalization of operations. This is a continuing thing. It's been going on for a long time. But the auto industry today is global. You give me a company that doesn't have global operations in the automotive industry. I can't think of any, right? And one of the problems is, while companies were profitable at small volumes in certain industries in the past, that's no longer holding. And companies have to do a completely different job to remain global and remain seriously global. That means they've got to have their information under control. Product data intelligence and PLM solutions are widely adopted to enable this. Really important. If you can't manage your data, and if you can't see your data, and if you can't share your data, you're in trouble. You automatically have a problem against your competitors. OEMs and contract designs of entire systems. Now, this is an interesting one. So we've seen a little switch here. About 15 years ago, the automotive industry went really heavy to contracting out systems. Like, I want to contract a company like Johnson Controls to do my whole interior of my car, right? The headliners, the dashboard, the seats. I want them to do the whole interior. The door linings, a lot of electronics, a lot of control systems inside the car itself. They kind of pulled back from that a little bit. What companies were finding is the OEMs were finding they were losing their own capability to do that kind of work, and looking at this and saying, wow, what if my big supplier fails out here? Or anything bad happens in the global economy around this, I'm in trouble. So they pulled a little bit back. What we're seeing now is they're going back out again. Most of the OEMs no longer have a parts business, right? They don't make these kind of components. It's not like the old days where you looked inside of General Motors and Delphi was sitting in there and they were the largest component supplier in the whole automotive industry. And they had one huge customer, right? It was GM. And Ford had what became Visteon. And all the companies were doing a lot of their own stuff. They're not doing that nearly as much. To support this, you have to understand how they buy and how you deal with them, and make sure that you're working, again, able to support a global environment, right? Because I'm not going to manufacture cars in one country. I can't necessarily do that anymore. I have to have local content, and there's a lot of things that go on in various foreign countries that make us worry about being able to manufacture in multiple regions. So we get the world car concept that has come out and become fairly important in this. We have regulatory stuff. Remember, regulatory things are things that you cannot control necessarily. You have to support them. And that's really important. That means you've got to provide for regulatory compliance data. That data better be accurate. You don't want to get caught out on what's going on. So there's a lot of safety stuff going on. What the OEMs are doing is adopting systems engineering. What that says is now I don't just have to manage my CAD data, I've got to manage all the requirements. And I have to understand when I fulfilled a requirement. That's hard to do. That's not something real simple, and we're only at the beginning of this. We're not anywhere close to being deep into the requirements management part of this. We have demand for other things here like electrical vehicles and much more stringent stuff around the environment that we have to go after. And we have to, again, be able to support that, deal with it, keep the data, find the data, maintain that information around those things. Brazil, Mexico, they require a high percentage of local content. I already kind of mentioned that, but Brazil is really a good example of this. If you don't have local content in Brazil, you don't sell there. We have a problem in Brazil because we don't have an office, and we have an enormous contract there. It's been a real huge issue. The contractor has to pay a whole lot of extra money to the Brazilian, or our customer has to pay a lot of extra money to the Brazilian government under their laws so that we can go work there. And it's really hard. And you have to ensure a smooth production across continents, right? If I'm going to introduce a new car, how do I introduce that across all these markets? The content may be somewhat different by rule, by law. Of a real sharp example, not in the auto industry, of this is chemical content. The rules in Europe are different from the rules in the US. And you have to comply with chemical content or material content rules across these countries. Therefore, you have to manage that and be able to react and change your product up based on that. We want to reduce manufacturing costs. So, support data transfer to production. 80% of the cost is determined during the design. Jim mentioned this earlier. 80% of the cost is determined by the time you get through your design process. and release to manufacturing engineering, right? So by the time you go out into this manufacturing area, you can't change the cost of your product very much. By the way, the red line on here is what you've spent. And this actually is not a very good drawing. This drawing should be way down here. You've spent, by this point, somewhere between 5 and 15 or so % of how much money you're going to spend developing the product in engineering. So in that small spend, with the people that are involved in engineering, and Jim had an interesting slide early on with lots of little people on a scale. How many are engineers? How many are global engineers? How many are users of the data? The number of users is massively higher than the number of engineers. And a lot of those users are right out in here, right? The engineering guys are here in the early part. Now, there's lots of other users in here. You need to keep their costs down. But you also need to be able to, in this period up in here, I want to do lots of iterations. I want to do a lot of trials. I want to experiment. I want to innovate. And if I can't innovate during that, I lose my opportunity to innovate on a product by the time I release to manufacturing engineering. So real important here. You know, transferring data is to manufacturing is often a very manual process. We go out and work with a lot of companies on their strategy around PLM, and then we do system selection and that sort of thing. The number of customers that we have right now, ongoing consulting projects with companies, where we find at least some manual process in transferring the bill of material from the CAD solution to manufacturing is enormous. More often than not, companies are still moving the data semi-manually. And the opportunity for error in the data is huge. Now, can you completely automate that process? Probably not, because we've got some problems. The bill of material that we use for the design side might turn into 4 or 15 bills of material on the manufacturing side, depending on plants and their capabilities and all of that. So unless you can do some really clever mapping of what those plants and various facilities can do, you can't automatically just generate a bill of material for them. Manufacturing engineers have to get in there and do their thing, and that's okay, right? We're seeing a lot of work being done in that area, by the way, and we are seeing some advances in that. And then the other thing here that's really, really important in this is change impact analysis. How do I manage change? How do I understand the impact of change? How do I understand what that impact is going to be, both on the cost and then on my future profitability of my product? How do I deal with the fact that if I have to change something like a material, what does that do to me? Do I still make money on the product, or have I just priced myself out of the world, right? So I have to be real careful around that. Design requirements. So, you know, lightweighting of vehicles, how you can modify structures using different, often lighter and cheaper materials. One area that we're seeing an enormous amount of work, and this is going to be a game changer across a lot of industry, is additive manufacturing. The work that's going on in additive manufacturing right now is absolutely amazing. Some of the capabilities are truly unbelievable from my old days when you constructed everything out of machine parts or out of casted parts and then you machined them. With additive manufacturing, you can make things that we never even dreamt of making in the past. So we are beginning, well, first of all, we're beginning to see people do true manufactured parts for product using additive manufacturing. We're seeing it in the aerospace industry. We're seeing a little bit of it in the auto industry. It changes the whole design paradigm. Complete shift in how you design the part. And when you get into things like composite parts, it really changes the design paradigm. because all of a sudden I go to certain kinds of additive machines, printing machines, and I can print layers of different materials. So I can do things that I never even dreamt of doing in the past. I can make shapes that I can't make by machining. Right? We had there's a local company that makes molds, and they came to one of our little conferences and spoke. And the interesting thing they were doing with additive manufacturing is, if you know molding, injection molding or any kind of molding, one of the problems is I have to get the material throughout the mold as uniformly as I can get it there. And so cooling of the mold becomes really, really critical. Well, if I look at standard mold manufacturing capabilities, I can make multi-part molds, but if I want a cooling path through one of these things, how do I get it there? I drill it, right? I have to be able to go with a linear process and make my cooling paths. What they discovered is, through additive manufacturing, they could go in and make very unusual, complex cooling paths that went precisely where they wanted them to go, and do the engineering analysis, by the way, to assure that the cooling is uniform. They're not cooling something off too quickly so that the material in the mold can't flow to the next part of it, right? Or it gets there and it's just not the right temperature composition, or it shrinks, or it does all kinds of things. So lots of stuff going on here that's really, really interesting. And then some others, innovation via software. So we do a lot of work in the automotive industry. One of my automotive friends told me this was just recently, something on the order of 60% of all new functionality that's going into mainstream cars today is software driven. And that's a huge departure from, again, just a few years ago, where most functionality that was going into new cars was mechanical driven with electrical controls. Now, a lot of the stuff is completely software driven, right? When you've got your V8 car or V6 car, or whatever it is, and you get out on the highway and the car wants to drop out 2 cylinders, that's all electronics. Yes, there's a mechanical component to how those cylinders get turned off, but turning off the fuel and the, when to do that and how to do it in the cycle of the engine operating at high speed, that's all electrical, or all software driven, right? Your sound system, all your systems in your car. Jim talked about Industry 4.0, really important. There's many other things going on here, like China 2025 initiative, which is really Industry 4.0. We have Industry 4.0 here, and there's in Germany, and he brought up Germany and how they're treating this. There's a whole lot going on here, and what is happening is companies are being forced. In China, what we're seeing, by the way, is companies are being forced to go the PDM route to get their data in control, so they can go out and start to manage it and deal with some of the issues they're going to have around the next one, which is IoT and smart connected products, right? So Jim gave a really, I'd never heard the sponge example, but there are lots of other examples of this. And there are lots of savings to be made, and there's a lot of data out there. In fact, there's so much data out there. One of the things we've seen with some of the companies that we deal with that are doing a lot of IoT, they have begun to actually decrease their data sampling rates. They realize they're getting way too much data back. But if you look at the aircraft engine manufacturers today, their engines are very, very highly, how do I want to say this? Automated is not the right word, but they have lots of monitors in their engines. And they are measuring what's going on in that engine continuously during flight. And getting that data back, and then through the concept of digital twin, right? I want to keep a digital representation of every engine I've got flying and its current as maintained configuration, so that I can run that digital engine I can simulate its operation compared to the one on the aircraft. And I can download from the aircraft what are the operating conditions, so what's the temperature of the air coming into the engine, what's the humidity, how much dust and dirt and crap is in there, right? What's going on with this? What's the heat of the whole engine? I can start now to simulate that, and I can be very, very predictive of I'm getting an oil failure. So, you know, the next time that plane lands, I want to do an oil change on my engine. I want to do a lubricant change. So lots of good stuff here going on, right? A best-in-class Tier 1 supplier. Be responsive to your customers. So to do that, you've got to have your data in order and be able to understand what your customers want to do. Track and manage rapidly changing regulations, right? You have to control your purchasing material, your overhead, your capital, all of the things that allow you to operate as a company. So you better have good information. You better understand what the cost of doing business is, right? Where are you going to source your product within the supply chain, both internal and external, to maximize your potential profit? Identify and manage core competencies and outsource the stuff you don't do, right? If you're not a composite manufacturing organization and you're designing composite stuff, get that out to somebody who knows how to build it. Deal with it that way. And then be an innovator. Manage so that you appear to your customers as an innovator. That keeps your customers happier, and that keeps more business coming to you guys. And again, to do that, you better have real good control of your information. Proactively manage your product and project risks throughout the life cycle. So you have to understand what are issues, what are risks, what are changes that are going on, who's responsible for those, what is the potential impact of those things, how do I deal with them. So control the changes against the product information. Regulatory compliance is an integral component of product development. The regulators are another customer, right? You have to deal with them. You can't ignore it. And therefore, you've got to get your data under control. We really see this in spades with medical device, where the regulations are pretty bad. So, and there's other industries where there's really tough regulations going on. Manage your IP so that you differentiate yourself for your customers. So your customers come to believe that you're that company that can satisfy their needs all the time, right? And then finally, drive everything by intelligent requirements. Now, it's, as I said earlier, requirements management right today is not an easy process. This is difficult. Nobody has a perfect solution. IBM with doors and their rational products is not perfect. Siemens with their requirements management product is far from perfect. Nobody has a perfect solution. And so it takes a little bit of work to do this. But it is still all part of this PLM world. And then what's typically required? A life cycle approach that looks at these areas here. So this is not only about product data, it's about the processes that you use to modify that data and work with that data. So remember that those two go together. Without the processes, your data doesn't mean much. If you don't know how to deal with it, and if your people don't know how to deal with it, your data doesn't mean much. Some key PLM enabling support area domains, and you know, these are all areas where product data intelligence can give you some support. Here's a whole list of them. Normally, when we're working with a company, we'll go through these with an organization and say, hey, is this one of the areas that you're concerned about? Right? I don't have a lot. I had to take out some slides out of my presentation, so this is one area where I took a bunch out. Let's talk about some best practices real quickly. I have slides for each of these 6 areas right here: project planning, change management, configuration management, part classification, engineering, and requirements management. I'm not going to spend a lot of time on them. Where am I on time? About 10 minutes? I'm only halfway through. So just remember that each one of these areas, there's important stuff going on here. If you can't manage what you're doing, you're in trouble. So you've got to be able to manage your projects. And you have to be able to manage your portfolio. You don't want to build things you can't sell profitably. So don't do them, right? Change management. Change management and configuration management go hand in hand. And if you can't manage your changes and changes to your configurations of products, then you get lost in the desert, right? You can't supply to your customers what they really need. And another part of this for the automotive suppliers that are involved here is what happens when your OEM tells you, I need this change, go do it, right? I have an immediate thing that I need to do. I need to understand what's it going to cost me to do this thing, and what can I extract out of the supplier to pay, or out of my customer to pay for that. So I better get that cost right, because there's two parts of this. I can overcost and tell my customer, and my customer can say, screw that, I'm going to go to somebody else. I can undercost and go to my supplier, and the supplier, hey, I'm happy. You're going to give me this for this kind of price? And all of a sudden I find out that I'm not making any money. In fact, I'm throwing money out the door on that. So I have to be really careful around that. You got to get it right, right? Configuration management, again, this goes hand in hand with change management. You have to be able to understand the configurations of what you're building. If you're working for more than one OEM, configurations of something like a seat can be different. Different control systems, different heating systems, maybe a heating system and a cooling system, right? So there again are all different configurations of things that you need to be worried about, and you've got to be able to manage those and understand them. Part classification. So being able to leverage standards, standard parts, being able to find things, classify internally, and then go find things. Jim earlier talked a lot about being able to do things like 3D search. How many of you can do 3D search today? One. Yeah, that's one person in the room. That's not good enough. The issue here is if I can't find the thing that's similar to this glass that I've got to build for a new customer, how can I accurately cost? I got to be able to find that. And by the way, when I find it, I have to be able to find all the attribute data around it. I have to understand what it's made out of, because maybe my new customer wants this out of a plastic, not glass. That changes the dynamic of what I'm going to do, right? The other thing is, how much of the stuff you're building today have you already got multiple copies of? We have a client who builds consumer products that saved, I don't know the real number, but I will tell you it was tens of millions of dollars by doing a catalog search through their database. And what they found was, in some instances, they had 20 replications of the same thing. Sometimes they were dead-out replications. The only difference was part number. And the reason the part number was different is they were being built or used, consumed in multiple factories, where each factory had its own part numbering scheme. And they had no clue that was going on. And what they quickly discovered was, in the way they saved millions and millions and millions of dollars, was going back to their suppliers and saying, you're supplying this over here for this price and over there for that price. And by the way, I've got another supplier supplying the same thing at this price. You're all going to this low price. Don't go to the low price. I got another guy who will. And so through that coercion, with data to back it up, it was like, hey, you don't lower your price, we're going away from you. And then consolidate all those part numbers into big buys instead of a whole bunch of little buys. And get much better discounts and that sort of thing. Engineering, concurrent engineering, collaboration, whatever you want to call it, right? How do you support that? How can you do that? How can you share the data? What's the right data to share? What's the right copy of the data? What's the right level of data that I can do there? Can I go model-based instead of drawing-based? So, yeah, we still have a lot of customers, again, that the drawing is the master. When we define the master, by the way, the question we ask our customers is, what do you sign off on? And by far, it's the drawing, not the model. Should be the model. The drawing is just a derivative. I'm at a point today in CAD solutions where I can almost push a button and produce all the drawings I need. Right. Then there's the whole thing of PMI, product manufacturing information. Where does it reside? Well, for the last 100 and some years, it's resided on a drawing, never in the CAD model. Now we can put it in the CAD model. Now I have less reason to have a drawing. Another whole issue around drawings. We're finding a lot of our customers can't hire people for the factory that can read drawings. Drawing is still being taught in schools, but not in the same way. So people aren't learning how to read physical drawings and how to deal with physical drawings and interpret them properly and that sort of thing. There's a real need these days to go to 3D representations, viewable representations at the factory level to get the information across to people. And we see some enormous, enormous organizations with unbelievably large, complex products doing this. And a lot of it's experimental today, but they're trying to get there. So, requirements management, use well-documented requirements, right? We're really rapidly moving to a systems engineering approach, either model-based systems engineering or systems engineering, but model-based seems to be the direction most companies are going, where the model can be a low-level mathematical model, 0D, 1D, 2D models, all the way up to a full 3D representation. The problem with the 3D representation, you get there way too late to make some key decisions about the products that you're building based on your requirements or your customers' requirements. So the 3D model, you know, if you look at the common V structure, the 3D model is not produced until the bottom of the V. And that can be months and months and months into the development. And it's too late to validate that you're doing the right thing. So you need to be able to do requirements management and validation in a way that allows you to make your decisions much earlier. I'm going to give you one here on selecting software. So this is our methodology for selecting software, our best practice. And I want to just I'm going to walk through it pretty quickly. But the point I want to make, always, always, always start with the business objectives. What is your company trying to do? You don't buy software to buy software. You buy software to support the business. If the software is not supporting the business, who cares? Get rid of it. It's a cost and it's unnecessary. So start with your business objectives of the organization. We actually, when we go to companies and we're doing a product data management selection, we start with what the managing board of the organization is putting up as their highest requirements. Now we break those down because you have to get them down to a level where they can impact the product development. But that gives you, you know, where does the business want to go, and what's it doing? Then there's two sets of factors that you need to look at. On the right-hand side are external things that you cannot control, regulatory stuff, your customers' requirements. You might have technical requirements, right? The space shuttle engines were based on what could be shipped by rail from Utah to the Gulf Coast. So those solid rocket boosters that were used on the space shuttle were sized very specifically with what they could put on a train, because that's how they had to get them there. Often we have products, you know, vehicles and other things that are sized by aircraft, lift capacity, size of space inside the aircraft, that sort of thing. So there's external factors you have to deal with. Don't necessarily have a lot to do with your product, except they sure do influence where your products need to go and where your business needs to go. Then you have your as-is situation. What are you doing today, and how do you want to change it? Right. So you need to kind of document your as-is situation and what you can't control. And then what you get out of that is, hey, if I can't control it, maybe I have to do some changes so that I can control it, right? And what do I want to do in my new world that I can't do in my old world because of the way I do business today and how I'm driving things, right? And from that, you get a vision and you get some good information on how you're going to improve your processes internally. Processes are very, very important. It's not just about managing data, it's about managing data and how that data interacts with processes. So that vision, though, has to support your business drivers up above. And, yep.
Sorry, we have a question from
okay.
the web audience. Are there any trends that suggest certain types of manufacturing companies are adopting PLM and data intelligence faster than others?
Yeah. So are there trends that suggest that certain types of companies are adopting PLM faster than others? Yes. The old line trend was this came out of automotive and aerospace and defense. The trends today are highly regulated industries, so it's much more high-tech electronics and medical products are the big drivers. And then there's a whole slew of others that are out there. So most industry areas that we're looking at today are growing pretty rapidly around the PLM area. One of the funky ones is apparel and footwear, where the variation and the criticality of how you manage your product line and how your product line rolls out over the seasons is absolutely critical. If you don't get that right, if you miss one Christmas sell, you can miss half of the profitability of a company instantly. Really mess it up. So you have to be really careful. And that applies, by the way, to all consumer products. So if you look at phone manufacturers, they can't miss their next release of their phone by very much because their competitors are all releasing new phones too. And as soon as you get behind one of these things, your competitor snaps up market space. So you look at Apple and they're continually pushing and pushing and pushing on how fast they can get the next phone out and how much improvement they can put in, that sort of thing. So, okay?
Thank you.
Yep. So out of this, the other two things you have to look at is your IT and your product information over here, right? And over on this side, your business processes in your organization. So those factor into this. I can't necessarily change all these, but I sure want to accommodate them, right? So define the information, IT and data requirements, and then over on this side, make sure you're supporting your business processes, and then from that you get an improved process and business control. And this allows you then to go do innovation. We use all this data to actually get us to requirements now for the hard systems, a CAD solution, a PDM solution, of visualization tool, whatever it is, right? There's a balancing point here too that you need to understand. Speed and thoroughness. You can do things really fast, right? Get to implementation, kind of on the left side, but don't forget that if you don't get buy-in from all the user community, you're probably in trouble. So worry about the right-hand side of this as well as the left-hand side. And it better be acceptable to the users. The thing here, cultural change, political battles are going to happen with any major change like this. And again, we see it with CAD, we see it with electrical CAD, we see it with in the architectural world, we see it with PDM systems. don't take away my Excel. That's often a problem, or my SharePoint. By the way, I am going to say it, SharePoint is not a PDM system. We've not seen any company that tried to adopt SharePoint or what's the other one that is similar to that as a PDM system that was successful with it. They always run into a problem, ultimately. These systems are not set up to handle all the interactions and interrelationships of the data that you're trying to handle, plus the complexity of the data and the size of the data, and it goes on and on. So, don't try to do that. Political battles, though, will happen. The limiting factor in almost every case that we see is not technology, it's the willingness of the people to adapt to the processes. Where the technology does have an impact on the processes. Now, it's great. We don't want to change processes necessarily. I will tell you that when we go into a lot of companies, we find really broken processes. So we do try to change those. But, as Jim was saying earlier, the idea is not to force a change in the process to meet the tool. The idea is to force a change in the process that makes the process better. And if the tool supports that, all the better. That's even better yet. So remember that little thing. I've got just a few concluding remarks. So, are you too busy pushing the bicycle to get on and pedal? Right? A lot of people are. You talk to them and they say, oh, we don't have time to go do that. So what are you doing? You're wasting a lot of time walking along next to that bicycle when you could be riding a lot faster. Now, maybe not this guy. He's kind of in the snow, but he's got the tires for it. Remember that every company is the architect of its own fortune. You have to go do the things that are right for your company to make your company work. And work better and better and better and stay competitive and stay ahead of your competition as much as you possibly can. And that takes a bunch of tools. So what about those worrisome things that I had up in the very beginning? Develop products in a tiered environment. How and what to share and collaborate on. Right? You've got to be able to provide the right information to the right people and then use the talents of all the people in the organization. I have a saying that I like to use. Everybody in your organization knows something about your product. We rarely find an organization where one person knows everything about the product, right? So you got to use all those talents. You can't just rely on one expert or one person to lead all that off. Global product development and delivery allow others to see your data while protecting your IP. Put it in a neutral format to allow people to see it. This is where Actify comes into the picture, particularly in their viewer technology. I want to be able to have people see the data. I want them to see it as though it's CAD data, but I don't want it to be the CAD data, right? I don't want them to be able to automatically steal it and go on and do something with it. And it can be well beyond the design data. One of the issues we're finding with additive manufacturing, when you build out the rules for how I'm going to manufacture the part on an additive machine, you're building into it a whole lot of IP about what that part is about and how to make it. And because it's done by a very flexible process, somebody steals that, they can go out and manufacture parts. And so you have to be real careful here. Pay attention to the right things, right? Reduce overhead of finding, seeing data, managing your data, take away all the bullshit stuff that people have to do. I go into one of these solutions and I create some piece of data. I should never have to enter my identification as the author of the data. That should already be known because I've logged into the system. I should never have to enter the date and the time and those kinds of things. There's a whole lot of stuff that we can put in automatically from knowing the context and what's going on, right? Finding time to innovate in an overcommitted business, right? Again, share your data across talents. Pull information out of those people that are experts at various things. and deal with it. And then being able to use and reuse your high value product information, share it across groups who don't have computer-aided, whatever X is. So put the data in a form that people can go look at it. They can work with it. They can extract value from it. Maybe they can change it and maybe they can't change it, depending on the individual, right? Have that control structure in place so that you're controlling what people can and can't do. And I think that's the end. Yeah. So, questions? Did I overwhelm you? All right. Don't hesitate to email me. You know, as I said, you'll get these slides. My email address is on the front. I'll happily give you a card before I leave. And we're always open to questions. So.
All right, thank you.